Good evening, everyone. We'll start with today's session. Our topic for the day is various piping engineering drawings and software, part one. Tomorrow we'll continue with the same topic, part two. So I kindly request everyone to mute yourselves. Chandramohan sir, we can start over with the training.
Okay, thank you, Anu. Good evening to all. Screen is visible to all.
Yes, visible, sir.
Okay. Today we are going to see our today topic is various piping engineering drawing and its software. Say part one. Tomorrow also we are going to continue the same topic. Today we are going to see only various piping engineering drawings only. Tomorrow we will see about the software which we are using to prepare engineering drawings. Okay. One second. Okay. Regarding piping engineering drawings, major drawings which we need to prepare, engineering drawings are plot plan, equipment layout, piping layout, isometric drawings, and its piping support drawings. These are all the drawings which we major drawings in engineering drawing while we prepare for any plant constructions or any expansions. Okay. First, we will see about this plot plan. Okay. And then before going into that, we will see that types of views used in piping drawings. First one is orthographic, second one is pictorial, plan and elevation. That one we will see in detail in upcoming slides. Okay, first we will see about the plot plan. So in this slide we are seeing that left one is there. That is the plot plan that you have seen in residential buildings like residential apartments, offices, like that. The right hand side is there for industrial one. Okay, so plot plan is the master plan locating. It shows each unit facility within the battery for a process industry. It also shows equipment and supporting facilities like pipe rack nearby. Inside the refineries, we need office buildings, of course, control rooms, security hut, and the tank farm, whatever it is, it will be shown in the plot plan. So one thing here I want to tell is in our residential plan, in our residential plot plan, now we have our regular shape. Like say it will be in rectangular shape or square shape, it will be regular shape. So it is easy for us to make the constructions, to make a drawings. But whereas in industrial area, we may not get the regular shape. Like if you see this plot plan, this is in irregular shape. This is where we need to apply our mind to make a optimized plot plan for our industries. So if you see this here, the irregular shape will be there. So we have to decide which area we need to construct our process unit, which area we need to install our tank farm unit, which area we need to install office unit, where the gate should be located. That all initially we have to decide based on the available land area. Based on that, we have to make for the plot plan. If you see here, this area and all not good for making a process unit. So they have selected this area to make any process unit or a tank farm, like that. So like that we have to prepare. Types of plot plan available is grade mounted horizontal arrangement, and second one is structure mounted vertical arrangement. In grade mounted means nothing but all of the equipments, whatever it is, like vessel, pump, everything will be located at the FG, ground level. finished ground level itself. Structure mounted is nothing but we will build one above other one. If space constraint is there or process requirement will be required by one above other, so that area we will go for structure mounted. Here everything will be mounted on the floor, that means on the concrete, PCC, concrete or RCC. Structure mounted means the name itself is there, structure. It will be mounted on the, some of the equipments will be mounted on the structural I-beam, like that I'm telling. And it will be structured on the, erected on the structures. That is called structure mounted. In most of the petrochemical industries, most of the chemical industries and all, they will go for this kind of structure mounted, because if everything, if you mount in the civil, grade level means, so you need from, if you want to transfer from one fluid to other tank, you want to transfer means every time you need pump. So this kind of arrangement will facilitate us, you can use the gravity to transfer the fluid from here to here. Because suppose if you assume one column will be there, there will be some overhead condenser will be there, reboiler will be there. So those kind of the things, according to the process requirement, even though if you have space, we have to go for the structure mounted vertical arrangement, so that we can facilitate to process our chemicals. What is the application of plot plan? What that team will we do with the help of plot plan? The piping team can use the plot plan drawing to produce equipment arrangement studies, piping and equipment routing with limited area, get an initial estimate of piping material. So the piping engineer, by seeing the plot plan itself, initially some group of all discipline people sit together. They will decide where we have to locate our office, where we have to locate our tank farm, like that. So let's say if gate is this side, this will be a main road means. So this area should be our final product. So this area we have to place our final storage tank. If it is hazardous flammable means, that tank farm should be far away from the process industries. If there is any flare, that also should be far away from the process unit. If cooling tower is there, that should be far away from the process unit to avoid the drifting losses, that water. So it will settle on the process equipments. So like that, initially, where is the control room has to be located, where is the office room should be located. The office room, it has to be close to the gate and easily approachable by the via road. So these kind of the things we will make in the plot plan. So based on that, we can we can estimate the piping requirement also from this tank to here, how much distance will be there. So based on that, we can estimate the initial piping requirement. That means costing we can do before proceeding for any greenfield project. And then civil team, they are the one going to develop the first plot plan. So they will, it will be useful for them for support design, grading, drainage plants, diked areas, pond, and all other material, mean warehouse where they are going to store the finished product or the raw material product, that and all. Based on the plot plan only we can decide. And then process engineer, they will use the plot plan for initial hydraulic design and line sizing and utility requirement. So next one is, what are all the input required for the plot plan? Equipment list with a number designation, so that only we can place the tank number, place the tank or place the pump, or place the column. So we will mention in the plot plan. And second one is block flow diagram. That is the process flow diagram. It is required, which indicating storage facilities, process plans, and the utility plans. And then specification indicating any, if it is special means it is maintenance requirement. If exchanger is there, so we have to give some space for bundle. If you want to, in future, if you want to pull out the bundle, there should be some space for in front of the exchanger, so that you can pull out the bundle. If you don't have space, we cannot make like that. We have to appropriately, we have to place the exchangers based on the plot plan available. And then existing site map mentioning geographic details like plant elevation datum, how much elevation it is from the datum, from existing coordinate, how much height will be, to avoid the water stagnation, at how much, at what elevation we need to build the process unit plant, that and all we get from the plot plan. And then what are all the input required for plot plan? To make the plot plan, what are the input is required? Preliminary civil drawings, preliminary pump house, compressor house, how much capacity we are going to decide, that and all it is required for make the plot plan. Preliminary pipe rack information, underground facilities, plant raw material, approach to the how we are going to approach the main plant entry. These are all the input required for the plot plan. Like utility requirements, cooling tower, it is coming or not, raw water sump is there or not, because raw water sump and cooling water will occupy more space. So we need to check before whether our process unit is required cooling tower or not, our process unit is required a raw water sump or not. Otherwise we can go for a tank, or we have to go for a RCC concrete sump. That and all based on our process. If it is power plant, our raw water is the main thing in power plant. So we have to give more space for raw water, like same like cooling tower also. And then area topography contour map, that is based on the location. So that one is contour map. And then any specific client requirement, that is any special plant means we have to consider before making a plot plan. And then 1 second. Okay, information contains in the plot plan. What are all the information we can get from the plot plan? Plant base coordinates in the true north and east, individual plants with their boundary and coordinates, roads with the center line and coordinates, geographical north and plant north will be there. Existing nearby plant, any details we can get from the plot plan. Location of major pipe bridges we can see from the plot plan. And then fences, gates, escape routes, etc. It will be available in the plot plan. So based on the plot plan only, further we can move for the next drawings to proceed to build up a petrochemical plant or a chemical plant. So plot plan is the base for all drawings. So second one, we are going to see about the equipment layout drawings. Equipment layout drawings is a detailing a conceptual layout. That is, if you are seeing here, this picture is showing the equipment layout. Before we have seen the plot plan, now we are seeing the equipment layout, where it is where we have to locate, which tank, from what distance we have to locate the equipment, at what height we have to install the equipment. Those things are available in the equipment layout. It is a basic document of mechanical engineering design and used for constructions. It is sometimes also referred as plot plan for large outdoor plant. So equipment layout is the next step of the plot plan. In plot plan, it will shows the overall, that means road, where it is main road, where it is the office buildings, where the control room buildings, where it will be a fire station, where it will be a garden, everything will be shown on the plot plan. In equipment layout, it will be shown only the process unit and a tank farm unit, so that we can further go in depth to calculate our pipelines, calculate our requirement, process requirements. So here we're seeing that this is an example of equipment layout drawing. If you see here, they will mention the every pump. If he has to reflex drum, this one is pump. This cross section elevation view, you can see pump will be at the ground floor, reflex drum will be at the first floor, some elevation. So here they will mention at what elevation we have to place the reflex drum, at what elevation we have to place the overhead condenser, trim coolers, like that. It will be available from the equipment layout. So first we have seen plot plan, second we are seeing the equipment layout. First only we will be from the plot plan only, plan view only available. In equipment layout, plan view also available, individual floor wise also. For example, floor wise plan view, floor wise elevation view also, it will be, a plan view also available in the equipment layout. So information contains in the equipment layout. 1 second. What are all the sterile areas around flares, vents, burn pits, major operating platforms, walkways, stairs, everything will be available from the equipment layout. Like I said earlier, true north and plant north, it is general, same we can get from the equipment layout. Wind direction, earthing and cathodic protection, bund walls, main equipment. Main equipment listed on the plot plan. Everything will be not only main equipment, even small equipment also will be available from the equipment layout. Input required to make the equipment layout. So first we need, definitely we need PFD, P and ID it is required, material handling requirement specification, equipment with the basic dimension. That means from initially we are going to prepare one, we decided to make one, install a new plant. We need the, first we need the PFD, then we need the PNAD, that side, that is process side. While construction side we will require, first we require plot plan, second one is equipment layout. In the equipment layout, at least we need the GA drawing of the individual equipment. So how length it will be, how high, how much height it will be, how much dia it will be. So based on that, we will locate the equipment inside the available space. We will see which is the optimized layout. It will be suitable for our process unit. So initially in any greenfield project, if it is expansion project, there no problem. If it is greenfield project, so initially we will make normally 2-3 types of plot plan. So one showing, one process unit showing this side, one process, one drawing will show equipment, raw material storage this side, final product storage this side. We will put option 1, option 2, option 3. So based on that, group of disciplined people sits together, they will decide which one is suitable to this process and suitable to this location. Same like that, equipment layout also we will decide that one. And then in what are all the other input requirements is wind and current direction, maximum wave height, and then electric, where we are going to install the electrical instrumentation panel, and then some room dimensions with operational and the maintenance clearance. Like I said, that like exchanger, same like that. If any lift is there, that one overhead space is there or not. If any substation is there, there will be underground cable entrance. That and all we have to see while deciding the equipment layout. What are all the basic consideration while making the equipment layout? So process requirements like minimum elevation, where it is, how much it is required, minimum distances where it is required, slopes, because of the chemical industries, and slope is very much important. And then ease of operational maintenance and the constructions. Consideration must be given for monorail, crane, and forklift for heavy equipment, because in between the equipment layout, we have the congested, we have a little space also. There should be some space for a vehicle movement. That should be a minimum 6 meter width road we have to maintain, because in future we may don't know which equipment we need to erect, which equipment we need to additionally we have to install, or which equipment we have to remove from the site. That and all based on the road condition only we can decide, because crane, heavy equipment like lorry and crane has to go inside and we have to lift the equipment. So that and all we need to consider while making the equipment layout. Information contained in the equipment layout. What are all the things we can take from the equipment layout? Like earlier I said, this one topography and wind directions, and then cooling tower, furnaces. What are the equipment available? That one we can take from the equipment layout. Maybe simple only. This one is piping layout. Next one is, we have seen that one. The one is piping layout, piping study plan, and final piping plan. So basically, a conceptual routing of pipelines based on the PFD and PNAD. All the conditions laid on the PFD. That means if from one tank to another tank some pipeline is going on, that one all initial piping we have to decide. So in final piping only, how much based on the hydraulic calculation, based on the line sizing only, we will decide the final piping plan. This is the piping layout drawings. Other name is piping GA drawings. Both are same only. You see this drawing now. This is the piping layout drawings. So for this is a plan view. From here you can see from which equipment the pipeline is going. In this one, we will mention the line size also. If it is valve is there, we will mention the valve size. If line is there, we will mention the line size. So from which equipment to which equipment it is connecting, everything we will be get from this piping layout. input required for to make the piping layout. So first we have seen plot plan, then we have seen the equipment layout. Now we are seeing the piping layout. To make the piping layout, first we need the PFD and we need the PNID. So PNID only shows the where that pipeline should start from, where should goes to. So these details we can get from the PNID only. Based on the PNID only, we can make piping layout. And then vendor drawing or information about the equipment, that is nothing but GA drawing, general arrangement drawing. In general arrangement drawing only it will be available, nozzle details will be available, so that we can lay the piping according to the nozzle. And then piping specification, to mention the specification of the pipe, it is carbon steel or is a stainless steel or what size, everything we will be mentioned in the piping layout, so that we require the piping specification, nothing but PMS. And then plot plan, obviously plot plan, equipment layout is the base for the piping layout. Next one is instrument hookup drawing, is that also required. It's a continuation only. Process requirement indicated in the PNID should be meet, because in PNID it is shown from one vessel to other vessel, it will have to show same like that, it should be indicated in the piping layout. So we have to cross check with the PNID while making the piping layout. And then only the standard pipe fitting special part mentioned in the piping specification should be used for routing. Okay, overhead piping should have clear headroom for manways and movement of cranes, trucks where applicable. Okay, these are all normal things. Application of piping layout. What we can get from the piping layout? They can help to identify the potential hazards and conflicts early in the design process. Yes, if piping, once you have fixed the equipment layout, then based on the PNID and PFD, initially, I mean draft basis, we will lay the pipeline in drawing. We will lay the pipeline from one equipment to another equipment. So by that time, if you connect the all based on the PNID, if you connect the all pipelines as in piping layout, we will come to know where it is fouling with the other pipelines, where it is fouling with the other vessels, where it is getting intersect. That all we can take from the piping layout. They can reduce the reduce the risk of costly mistakes. Yes, before we procuring the pipelines or procuring any special items, if we lay the piping, if we have the piping layout, we can before itself we can identify, okay, this one is fouling, so this routing it is not possible, we have to take other route. Because if piping layout, if you see now, it like nerves, it will go some everywhere, it will pipeline will be go. That's why we need where we to put the pipe rack, where we have to go underground. If you take fire water lines, while making the piping layout, we have to consider the fire water lines, because we made mistake in firefighting. Once we freeze all process piping, then we came to know the firefighting also comes into the picture. So firefighting equipment, I mean firefighting lines will go everywhere, to wherever the flammable substance is there, wherever the process unit is there, that fire water lines will go. So before itself we have to decide which line has to go to ground, underground, which line should be above ground, which one should be goes to the pipe rack. So that and all we need to take from the piping layout only. So and then here they have mentioned the conflict potential hazards like that. Now it is from the QRA. So that and all we can before itself we can identify the problems, and then to estimate the cost of the piping system. From the piping layout, we came to know which size pipeline is required more length. So accordingly, we can estimate the cost, piping cost, because the project will take a 3 years project or 4 years project. So we have to procure the items at the initial stages. At least 80% of the pipelines we need to procure. I mean, special valves, that may lead time will be very high. Some pipelines, special pipelines and all. If it is stainless steel pipe and all, we will finalize the isometric drawings maybe after 2 years only. So before initial, if piping layout, if we have at the initial stage, we can order some 80% of rough amount of pipeline, so that we can save the cost in the piping system, like valves, pipes, fittings, whatever. And then to obtain permits from the regulatory service agencies. The regulatory agency is nothing but a government body. So wherever we are going to install the plant, we need to get approval from the local government bodies like Pollution Control Board, Explosion, some there will be there, fire department will be there. So based on, they have to give approval to proceed further. So initially we have to submit. If we have this drawing, we can show to them, we can get the approval. So in last minute, if you construct everything, then they didn't give any approval, means it will be a huge loss. Because if any flammable substance you are handling nearby the tank or pump, then definitely we need a foam, we need a hydrant, we need monitors. So that and all before itself you can get from the local government bodies to get the approval. To track the progress of piping construction, that while you started to construct the plant, so every month or 2 weeks once we will see the piping layout, we can see the how progress is going, that one we can see. So next one we are going to see is a isometric drawing. We have seen, first we have seen plot plan, next we have seen equipment layout, third one we have seen piping layout, fourth one we are going to see the isometric drawings. The plot plan, piping layout and equipment layout all will be in scale. That means it will be in with the dimensions. If you put into the CAD format, 2D drawing, you can measure the distance from one end to other. Based on that, you can calculate the how much distance in between the equipments. Based on that, you can, so this pipeline will be 100 meter. This size of pipeline will be 10 meter. Like that, you can come to one conclusion. You can plan for that. So whereas in isometric drawing, it is the next stage. Once you prepare piping out everything freeze based on the P and ID. So next step, you have to make the isometric drawing to fabricate the pipelines. Okay. So in this isometric drawing, what it is not drawn to the scale, but it is proportionate to the exact dimensions presented. Similarly, like it is not to the scale, it will show the directions where it will go, north, south, it will shows. And then pipes are drawn with a single line irrespective of the line sizes. Yes, that is a major difference between the piping layout and the isometric. Whereas in piping layout, we make 2D and then we make to the 3D drawings. There it will show the exact pipeline sizes. Say 500 NB means 500 NB. Nearby any 4-inch line, it is going 4-inch, so that we can see the where it is get fouling, because for higher size pipeline this much space is required. So how many numbers of pipeline it is going, so that we can decide the pipe rack width. So if it is the width is going beyond the 3 meter or 3.5 meter, so we have to go for 2 tier, we have to go for 3 tier. Like that we can decide based on the piping layout. But in isometric drawing, it will be a single line size only, because center line only it will be shown, and then it will show the reducers, flanges and walls. The actual sizes are notified in the bill of material. In every isometric drawing, there will be a right side one column will be there. There will be showing the BOM, bill of material, and notes, whatever the special notes is there, fabrication, cut piece length, everything will be shown in the isometric drawings. Piping isometric drawings are popular because of their simplicity to convert to the complex information. So piping isometric drawing is the base for fabrication of piping. So this slide is showing now, this is the isometric drawing. In 2 days back, we have seen one isometric drawing, the same kind of isometric drawing. This is here the right side corner, they are showing the table. This table is showing the bill of material. I already explained this one. So here they will mention number 2 means we have to see here number 2. There they will mention the pipeline size, which specification, how much meter. So like that it will be available in the bill of material. So in this P&IDs, it is not one thing is not available. In some P&IDs, sorry, in some isometrics, we will give the cut piece length. Let's say example, this is number 1 means, so how much length we have to cut. So based on that, this is the final drawing which goes to the fabricator. He may be skilled, he may be unskilled, but by seeing the drawing, he can make the piping according to the isometric only. So it is not to the scale. it will not be, generally it will not be in the scale, but it will show the coordinate where it, I mean direction. So this pipeline is coming, going to east, and then it's heading to north, and it is going down, it's connecting with the some other equipment flank. Like that isometric it is available. So in fabric it is the BOM. Some table they will mention the fabrication details, like 1 inch pipeline, how much length they has to cut. So here it is showing a center distance. If you see this drawing now, here they are showing from this weld joint to the center of the T, they are showing 529 mm. But actual pipeline we have to cut is, we have to minus the T length, half portion of the T length we have to minus from the pipe, so that we can save the piping cost, I mean wastage of the piping material. So we will give, normally we will give the cut piece length. So how much T will be there? This is the standard dimension available. If 2 inch equal T means it is a ready-made item, it's a standard one, according to the standard it will be available. So based on that we will go for the fabrication. So how much the valve distance, valve length it will be all be available in the initial stage of the project, because then generally these valve dimensions are fixed. Some manufacturer to manufacturer, some variation will be there, but not much. So we can fabricate the piping according to this isometric drawing only. So what are all the inputs it is required for the isometric drawing? PNAD it is required. Yes, from isometric, if you see this isometric, it is shown some valves, mean some nozzles. So here they will mention which equipment, which nozzle number, everything they will mention. Let's say some example, it is connected to the pump suction. So they will mention here, let's say P1001 N1 nozzle. So like that. So it will connect to the suction. So that one we have to cross check with the from the PNAD. Before while checking the isometric, we have to cross check with the PNAD. Really it is connected to the pump or not, because mistakes will happen anywhere. In PNAD we may make mistake, or we may then doing mistake in piping layout, and then we may doing mistake in isometric. So once you before start the fabrication, we have to check all the isometric drawings according to the PNAD, as well as the general arrangement drawing of the any equipment, because general arrangement drawing only shows the equipment nozzles, where vent is coming, where a drain is coming, where is the pump suction, where is the LT nozzles and all, it will show in the GA drawing. So we have to correlate with the PNAD with the GA drawing, then we have to give approval for the isometrics, and then PMS. Obviously we need PMS. I hope you have already attended the training on PMS, piping material specification. In that I want to tell, the piping material specification is, before we proceeding for any project, we go for like say we go for a power plant, we are going to build one power plant, means before that we will freeze the PMS. What is PM is piping material specification, because different types of MOC, different types of method of pipes is available in the market. So which one we have to use for this project? Throughout the project we have to follow some document, that is the base for the mechanical piping. So in PMS they will mention the, let's say if for steam service, there will be different service will be there. For steam service, for DM water service, for condensate service, we have to go for a carbon steel pipe. For effluent pipe, we have to go for PVC pipe. Like that, it will be mentioned in the PMS. Why it is required for isometric drawing means, here in the right side column, I mean table, we have to mention the specification of the fittings, valves and pipes. So we have to take PMS. We have to feed the PMS in our 3D. So it will automatically we can extract from the 3D. That is different thing. But while checking, before we issuing to the contractor, here will be a revision table will be there. So initially first revision will go for internal review, second revision will go for another one. So like that it will go. Finally it will go for approved for construction or issued for construction. That will be IFC or AFC. That one will be initially we have, sorry, finally we'll go to the contractor side. We have to make our company shop here. We have to sign every isometric drawing before issuing to the contractor side. Once it goes to the contractor, he will blindly start the fabrication. Once if we done the mistake in the fabrication, it will mismatch in the field. Then finally it will cost us the time as well as the cost. So what is the application of isometric drawing? It is a drawing used by the fabricators to create detailed plans for the fabrication of piping system. So and then another thing I want to mention here is in the isometric drawing itself, we will be mentioning the field joint also. Let's say in this isometric, how many joint is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 joint is there. Out of this 12 joint, okay, drawing we cannot fabricate everything at the shop or everything at the field, because some joint may have to do at the site, because first thing is we cannot take this whole piece, handling will be a problem, first one. Second one is there will be some connection will be there. If you do welding everything here, there will be some deviation, some degree rotation will be there. That and all we have to do at the site, because to save the time we cannot do all the joints in shop joint. Same that to avoid the mistake, we cannot do all the joint at the site. It will cost us the time. So that one we will mention at the bottom of this isometric, which one is shop weld. You see here, this is the shop weld. This mark will be show as the field weld. So like that we will mention it normally. Fabricator or non-fabricator, the isometric drawing who is going to prepare, he will mention the which one is field joint, which one is shop joint. So and also fabricator also can decide based on the length of the pipe. He can also decide, because he is the one who is going to install at the site. And then piping isometrics used by the installers to guide them during the installation of piping system. And then used by the maintenance personnel to troubleshoot the problems with the piping system. They can be used to identify the location of problem and determine the best course of action for repair. Not only in the project stage, once the plant is installed, it will be in running condition also. If any flow is not there, or if there is any leakage is there, then we have to go search for the isometric drawings. Where is the flange it is available, where the valve is available. So where will be the problem, because if any blockage is there, some flow is not there, there will be some blockage. So which valve we have to remove, so we have which area we have to cut, like that and all we can take details from the isometric drawings. So it will not be used at the, not only used at the initial stage of project, that means fabrication time, also in the maintenance time also it will be useful. So general information about piping drawings, it covers the complete lines as per the line list and P&AD. There will be separate line list will be there, that is different thing. Isometrics are not drawn to scale, but should be proportional to the easy understanding. That is a common thing. So here we have to show this one is 529 means. This one we cannot show as a 1000. So proportionally the dimension will be there. So for easy understanding purpose, even though it is not in scale. Dimension is given related to the center line of the piping. So irrespective of the pipeline sizes, it will be center line of the piping. What are the following informations included in, available in the piping isometric drawings? So plant north will be available, drawing number. So which line number, which drawing number it will be available. Revision table will be available at the bottom of the isometric drawings. Reference number. We will give the each and every isometric, we will give the P&AD number, and if it required GA drawing number also we will give. If any equipment is involving in that isometric, we will give the general arrangement drawing number also. And then design pressure, design temperature, test pressure, everything will be available at the bottom of the isometric drawing. Coordinates, equipment number, and then line specifications, scope breaks, everything will be available. The scope break means nothing but which one is vendor scope. Some equipment we will buy, we will not fabricate, we will buy from the vendor as a package. Let's say from a DM package, DM plant, there will be some package will be available. So they will give the, it will, the isometric will show the which is the vendor scope, which is the client, owner scope. So based on that, it will be available in the isometric drawings. So we already seen this one. This plan and already seen. Here is change in the direction and angles of the line should be clearly shown. Change in the direction means nothing but it will show the north, it is going north, and then it has to go turn to east. That and all available in the isometric drawing. Also some rotation, some angle also will be shown. Everywhere it will not be 45 degree or 90 degree. Some area it will be show as a rotation. Some angle will be there, non-standard angle, 60 degree, 52 degree, 40 degree angle also, according to the process requirement we have to provide. That also will be shown in the isometric drawing. And then match line details and sketch identification, match line provision and accuracy of BOM and isometrics. This one is main thing. In piping layout we will came to know the approximate length of the piping only, but in the BOM in each isometric drawing it will be shown as the exact length of the required pipe sizes. So based on the BO, isometric, we will prepare the MTO. In every project, we will prepare the MTO to float for the purchase department. We will prepare the MTO, material takeoff. In that, clearly it will be there. So 2 inch, how many how many meters, how many kilometers it is required. So wall, how many hundreds it is required, which type of wall, everything will be available in the MTO, material takeoff. That material takeoff base we will take from the BOM. From P&D also we will cross check. We miss any pipe valves or not, because in isometric some valve will be shown in the, you see here, we will show this valve in the dotted. Why it is showing means another P&D, this continuously given a number. If you see this drawing number, it will show us a solid line, because this valve we already considered in the this drawing, so we no need to consider in this BOM. So this valve is shown with solid line, so we have to consider this valve in this isometric. So this confusion and all will be there in isometric. That one we have to cross check with the P&ID. Weld points and field welds already we have discussed. Insulation class and insulation thickness. Yes, in the line number it is there now. Here it is line number. If you see here 1 inch, after that process will be there, some project code, it will be given by the client. It is according to the client, they have their own pattern sometime, so we have to mention that one. And then we have to mention the process. If it is cooling water supply, we have to mention CWS, cooling water return, CWR. And finally we will mention the insulation thickness, how much it will be. 50 mm means we will mention the 50 mm, 100 means we will mention the 100 mm, or some area they will mention the HI like that. That is a human, to avoid the, it is not insulation is not only required for the prevent the heat loss, also for the human safety. So at the low elevation, some pipeline will go for higher elevation, that area not required the insulation. Whatever at the lowest elevation, human get contact with the pipeline, so avoid that accident, heat problem, we will give the insulation. So that entire minimum 25 mm insulation we will give. So those details will be available in the isometric drawings. Next one is, so this one we have already seen. Here it is shown. Field weld location, high point vent, where the high point vent will be, where will be the low point drains, that and all available in the isometric drawings. Special supports, and also main thing is in piping layout, we may not see the type of support, but in isometric drawing, we will came to know the type of support. If a guide support, or is a rest support, or is a welded one, anchored one, or is a U-clamp support, everything will be available from the isometric drawing. The support and all we will going to see in detail in upcoming training sessions, that we will take as a separate topic. That will be a bigger one. And then all the symbols are used as per legend. So by P&D, I'm saying isometric itself, there will be some legend will be there. Field joint, socket weld means what we have to show, butt weld means what legend we have to show, that and all available from the isometric drawing. And then slope also showed as per the P&D. Some process lines, as I mentioned earlier, some process lines it requires slope, that also will be shown in the isometric drawing. Bill of material we already seen. Tie-in numbers we already seen, because some existing plant we are going to extend the project, means we have to tie in to the existing pipeline. So that and also will be shown in the isometric drawings. and a spectacle blind it is required or not, or permanent blind is required, or any spaces required as per the PNAD, that and all will shown in the isometric drawings. So like that flow direction of items such as check valves, globe valves. Yesterday we have seen about valves. So flow direction is must for check valves, globe valves, and stainer. Yesterday we have seen same that the direction also will be mentioned in the isometrics based in the arrow mark. And then finally we are going to see the piping support drawings. Here I am showing the one sample. So these are all the support. This is the piping, I mean detailed support. It will not be shown in the isometric. Only we will show as a guide support, means we will show some legend is there. We will show the in the isometric drawings. So these are the type of support sample I am showing here. Okay, this is a pipe, I mean fixed support. It will be a guide support, shoe support with the guide. Everything is a support drawing. It is a pipe support is a designed element that transfers the load from a pipe to the supporting structure. This is the pipe. The load of the pipe and inside the fluid and the vibration, everything will be transferred through this shoe support to the permanent member. This is the secondary support. This is the primary support. So it will be transferred to the permanent member, that is pipe rack or sleeper, wherever whatever it is. The four main functions of pipe support are to anchor, to guide the pipeline, to absorb the shock from the pipeline due to some water hammer or sudden stoppage of the pipeline flow, and support a load from the pipe. The pipe itself having the self load, that and all should be supported. So this is a piping support drawing. This will be separate drawing for any project. Like isometric drawing is separate, same like that. Supporting philosophy, support drawings will be a separate one. Based on if see isometric, it will show the PS1. So in separate document, in support drawing, we will mention clearly what is PS1. If PS1 is guide support or not. If it is guide support, what are all the material we have to use? Like, so that complete details available in the piping support drawings. We will see the piping support drawing. This will be a common for the whole project based on the pipeline sizes, based on the temperature which it is handling. So it will be available. We will give the different name for each type of support, PS1, PS2. That depends upon the project earlier design. Client and consultant will sit together. They will decide which type of name we have to give, which philosophy we have to follow for which pipelines. Like PMS, we are preparing PMS. Same like that, we have to prepare the piping support drawings. And the input required for the piping support drawings. Same like piping layout is required. There we will show the support where it is coming. We will show the in the piping layout. And then structural drawings it is required. Piping support standard that we will get from the stand. I mean whatever standard available, ASME standard, sorry, shell standard it is available. We take from the standard. And then design basis, like I shown here this document. So the design basis will be there. And then piping and equipment DGA drawing. Application of piping support drawing. The support used to identify the type of support, because in isometric we show only the legend. So we will get the detail from the support drawing only. And it provides all details for fabrication of supports with BOM. Like I said, which angle you have to use. Some area we will mention PS1A. If PS1A means according to the pipe size, for 2 inch we have to use the 50 mm angle support. For a 10 inch pipeline means we have to go for a channel or I-beam. So those details and all will be available in the support drawing only. And also it will provide the schematic sketch of the support. So finally what it will be the final shape, that and also we can get some idea in the piping support. So these are all the things we have covered today training session. So thank you. Any questions is there, you can ask.
Thank you for the detailed session, sir. We'll move on to the Q&A. What are the necessary details required to prepare data sheets of strainer and steam trap? what all the details will be available in the data sheets.
But that is not related to this topic. Okay. In strainer, I mean, strainer means main thing is the fluid properties. It is they will mention, because in strainer, inside the strainer there will be a mesh. We will call it a mesh size is micron or mm. We will call it based on the viscosity of the fluid, based on the temperature of the handling fluid, based on the pump, or based on the downstream equipment. If it is exchanger, it could be an exchanger, it could be a pump, or it could be a compressor, whatever it is. So in viscosity, after the operating temperature, operating pressure, and the fluid properties. Mostly it will be fluid properties only. And then pressure class. If it is a sometime we will use as a Y type strainer, packet type strainer. The different types of strainers are all available. Based on the flow, if it is a bigger size one, we have to go for the bucket type strainer, where we expect the more sediments, like cooling water side or raw water side. We may expect the more sediments or more impurities. So that and all, where we have to go for the bucket type strainer. Like a steam service and all, we have to go for the Y type strainer, and mesh size will be differ for cooling water too, and for a clean liquid like a kerosene, like a diesel, like a petrochemical products, I mean hydrocarbon products. There will be different in the mesh size. Micron size will be differ, because in water, if you are going to put 5 microns, so within 1 week it will block the whole strainer. There will not be any flow to the pump. So in a clean liquid, we have to put the fine mesh strainer. So there will not, definitely there will not be a much impurities, because it is coming through the various process from column to reboiler, from reboiler to exchanger. So that and it will come. So there will not be much impurities. Based on the fluid only, we have to decide the strainer. But input in complete data sheet means that we have to check with the process only. So generally process people only will give the data sheet regarding the handling fluid. Our side, mechanical side, what we will see means only the pressure rating and the temperature rating, because that mesh, which material we are going to give, whether we are going to be in a fiber, or it will be in a nylon, or it will be in a stainless steel SS mesh, or will be based on the fluid temperature and the fluid pressure. And then flange pound rating. What will be the upstream pressure based on the, if it is flange means we have to mention the flange pound rating. And then hydro test pressure, that and all we have to mention in the data sheet.
Next question. Points of installations of instruments like transmitter or gauges are not shown in isometric. Why?
Sorry.
Points of installation of instrument like transmitter or gauges are not shown in isometric. Why?
It is piping fabrication drawing only. No? Isometric drawing is not for a whole discipline. It is for mechanical only. There they will show only the tapping point. Only up to mechanical only we will show. Electrical and mechanical, I mean instrument will not come here. We have to check with the PNDD only. We will show, if suppose let's say in pipeline, so let's say piping pump discharge is there. There we will show up to our mechanical scope only. After that, it will comes to the instrument scope. Let's say from 4-inch pipeline, coupling will be there. After that, 1/2 inch piping. After that, one valve. After that, there will be one flange. Up to that flange, our scope is over. Mechanical scope is over. After that, pressure gauge means that instrument has to discuss with the mechanical at what we have to discuss with the instrument at what size they want. Based on that, we will take tapping and we will close. Generally, instrument and electrical we will not shown in the isometric, because it is purely for mechanical fabrication purpose.
Next question: difference between BOM and BOQ.
Both are same. That is bill of material, this bill of quantity. No different. There is no different. It's a term only different.
What is major pipe bridges?
Sorry, major
Pipe bridges. What is
pipe.
bridges?
Pipe bridges means I think he's asking about the support. We will call. So he's asking about support or any overhead piping. I'm not sure. Piping bridge means we call as a pipe rack only. Piping wherever the road crossover is there, there we will make the piping bridge. Not only as far as I know, but I'm not clear what he's asking about.
Okay, so we'll move on to the next question. What is the actual involvement and prime duty of piping engineer in preparation of these drawings?
He's asking roles and responsibilities. Look like.
Yeah, on preparation of drawings, what is like the duty of like piping engineer? I think that is what he's asking.
That is what we explained. We that in final session we are going to see in detail about the roles and respond. Our training topics is there. There we will take in detail roles and responsibility of piping engineer. Here you have seen we have to cross check. Prepare the isometric drawing means we have to cross check with the P and ID. We have to check with the PMS piping material specification in which wherever that material is located we have mentioned or not, that one only we have to see, and then we have to consider mainly we have to consider the piping support. Based on the analysis we have to what type of support is suitable for the which pipeline, that and all we have to check. So we will see in detail in a final day, I think. Okay, next.
Yeah, next question. How to decide the elevation of the pump and other equipments?
Elevation of pump is mainly depends upon the available head, static head, how much it is available to the pump. Because any pump we are going to buy, in pump data sheet we have to mention the NPSH available. We have to mention to the vendor. So that one, and then downstream where we are going to pump the fluid. So the downstream pressure we have to know. So based on that, we have to give the data sheet to the vendor. So if it is a positive suction pump means, that means if it is a big column is there will be enough static head is available. So the elevation is not a problem. Only thing we have to check the feasibility of approaching the valves and for maintenance purpose. So we have enough head. So we cannot install the pump at the 2 meter elevation. So it will be hard for maintenance and for inspection of pump or removal of pump. So generally, if we have the enough static head for the pump, mostly the pump high foundation, that is from the ground level to the pump center line, it will be hardly 300 to 400 mm only. Other equipment is based on the process requirement, based on the contour that plot plan, because where it will be a lower elevation. So obviously that equipment we have to install above the ground, the foundation will become above. So if it is column, so we have to give enough head to the pump, that column should be installed at some elevation above the pump. There we have to go for the skirt support, we have to erect the column. And some areas we have to drain the some tank to the nearby the sump. So obviously we have to elevate the tank to the highest topmost elevation. So where some reboiler we are going to install means it is going to overhead, vapor will become at the top of the column. So again we cannot take the vapor to the top one. So we have to bring the condenser to the top of the near to the top of the column nearby platform. We have to locate the equipment. That is, we will decide on based on the PFD only. So first we have to freeze a PFD, then a PNID, then only equipment layout. In that equipment layout, we will come to know we have to reduce the pipeline length, to reduce the pressure loss, to reduce the friction loss. We have to locate the downstream equipment as close to the pump. So these are all the factors we need to consider while deciding the elevation of any equipment. If it is rotary equipment, it is different. If it is static equipment, it will be different.
What is the safest distance of flare from process area, and in what basis the height of flare will be selected?
It's not relevant to this topic. I am also not sure because we will first that flare output. I mean, first we will see the surrounding the flare area. We will check the process unit. Basic only I know. In depth I didn't know about much in this one because hack and all comes into the picture. Hazardous area classification will come to the picture. So nearby the flare area, there will not be any hydrocarbon storage. 1 second. Okay, sorry for the interruption. That is purely based on the hazardous area classification. So some standard will be there. I'm not sure. Initially, while installing the flare 5 or 6 years back, I came to know we will measure the distance between the process unit and measure the distance from the raw material storage and final product storage tank. Then we will make one boundary for the flare. That and all we did, but based on some calculation from the external agency only we did. In much detail, I don't know about the flare. So next one. Actually, okay, next one.
Ma'am, attendance link, ma'am.
Okay, okay. Sorry for the interruption. Okay, I'm reading the question because it's leaving. I'm reading the questions. What are the necessary prepared stainless steel trap we have seen? Once again. At what stage we will freeze the plot plan? Okay, based on the available land area, we will initially we will make some arrangement where it will be the process unit like that, because process unit you may require for the straight length you may require for free space, because there will be some process unit you cannot here and there you cannot locate the equipment, there will be some continuation will be there. So based on that, in available land, because we may not get the regular shape, okay, we may get the irregular shape of land. So based on that, where will be the our process unit where we can locate, we can first we will freeze the process unit, then we will discuss about the raw material storage, where will be the extreme end of the plant, because if any accident happen, any fire incident is happening in the process unit, it should not affect the raw material storage tank one. So we will locate the storage tank far away from the process unit. So after all freeze this one, we have to apply to the local body, government statutory requirement. We have to fulfill the statutory requirement. We have to apply to the local government agencies. So from the government, there will be a separate department for this industries development. They will come and see the, they will approve the plot plan. So that time only it will come to the final one. Before that, according to our requirement, we will modify the plot plan. So that time only will come to the freeze. And then is piping layout and piping routing is same? Yes, both are mostly the same. 90% it is same only. Piping layout is, piping routing is we have to decide before making the piping layout, because from one area from one, if we see from one compressor, the discharge line, I mean our discharge line has to go to the some other tank, means some from receiver, air receiver tank, means it has to go, that we have to decide it has to go to the underground or it goes to the pipe rack or goes to the above ground. We have to decide that one based on the site requirement. Piping layout is after all fixed these things, then we will make the layout drawing only. That is only piping layout. Piping route is which we will decide. Piping layout is, it is showing the piping routing. That is what difference between these two. And then what is the major pipeline that we have seen? Okay, it's coming again. Point of installation, that one gauges are not shown by we have seen. How to identify overlapping of equipment in layout, a vertical drawing. We can clearly see. You are asking about the structure mounted vertical drawing. That one we can see from because every floor, each floor now we are making not only if it is 3 or 4 tier platform, platform drawing is there. We will make a elevation drawing from view from one side, view from other two sides. We will make until we get the clear picture of the drawing. I mean equipment. Each and every document will be seen from one end to other end. If it is not visible from this one end, if it is train 1, train 2 will be there, both will be identical. If you see, if you stand in front of train 1, if you see train 2 will not be visible. So 2 elevation, 2 sectional view drawings we will make, and each floor we will make the floor plan, first floor, second floor, third floor, like that. From that we will definitely we will come to know it will overlapping or not, we will come to know. That is not a problem. What is meant by the mobile pressure vessels? That mostly we will not use that one in shutdown time and all. We will use air receiver. Let's say if you take the turnaround shutdown, that time your all equipment will be under shutdown. Okay, let's say if you need the compressed air for cleaning all your equipment, so I turn around shutdown. Okay, so until cleaning all your equipment, you need the compressed air. So while you want to do that one stage at the end of the turnaround shutdown, you have to do maintenance at the air pressure vessel itself. So that time you don't have a compressed air to clean the pressure vessels or to test that particular air pressure vessel, air pressure vessels. So that time you have to go for the external agency. There will be external mobile compressor along with the air receiver, it will be available. So that only we call mobile pressure vessel. Some area we will get the boiler also. Some area it is available as a mobile. So wherever the boiler shutdown is there, it may go for a month together. So that area we may need a minimum steam to run our plant or for the process requirement. That area we will go for the mobile pressure vessels. That is what mobile pressure vessels. What is difference between the north and plant north? North and plant north we will call as the true north and plant north. Okay, true north means based on the topography, it will show the true north. That is from view from the satellite view itself, we will know that if you open the Google Earth, we will come to know the which one is north, which one is south, like that. That is the true north. A true north and plant north will be different, because plant north we will make according to our plot plan layout. We will rotate the north direction according to our plot plan. That is the plant north. There will be some deviation between the true north and plant north, because to make the individual drawing, for make the piping layout, to make the equipment layout, we need the north direction. We will indicate the north direction. That we cannot mention the plant north because it will be irregular shape. So we have to rotate our drawing to some according to our drawing. So based on that, we will rotate our drawing. So that will be the plant north. So in most of the plant where they have true north and the plant north, it will be differ. These plant plan preparation based on the best practice, based on the experience or standard, or by the specific international codes and standard. It will be based on the best practice and based on our requirement only. Because initially, definitely we are going to put the plant in the away from the residential area. Okay, then only government will allow. So based on that one, we will go for the construction. Before going construction, we will see our feasibility, because plant to plant, process to process, people to people, management to management, that their thinking will be differ. Okay, some persons in my future, I mean in past previous plant and all, we will see the vastu. We will see which area that road transport will be there, in which area the raw material storage will be there, in which direction that final storage will be there. Then we believe in, if we locate the final product storage tank in this direction, it will give profit to us. Like that, people and all is there. They will see the these kind of things. So it will be purely on depend on the management, but at the same time there will be accessibility for the local firefighting agencies to approach the plant in case of any emergency. Also, we have to get approval from the local explosion fire and explosion department will be there. They have to give approval to our plot plan, because all around our equipment there will be some approach should be there. We cannot occupy our full land there. We have to lay a 6-meter wide road around our plant to mobilize our the local government fire tender, everything. Those kind of things we have to see. There will not be any specific standards or codes. PMS is required for PMS required before layout preparation. At what stage exactly the PMS and the major MOC will be finalized? At the PFD itself, we will finalize the PMS, because we are not going to put any new plant or new chemical. We are going to put any plant we are already based on their experience, based on the trial and error method. They already defined piping material specification. So right now, if you ask anybody, they are not going to put stainless steel for cooling water, or PVC line for steam service, because based on the previous experience, based on the codes and standards, we have our already we have some 90% PMS is finalized for any project. If any special chemicals you are going to handle, or you have what we have concern about the safety, they will go for the higher schedule. In some area, they will give lowest priority to safety. So that in area they will go for ERW pipe for fire water pipelines. In some plant, they will no, we will go for we will go at most important safety. There they will go for seamless pipe, schedule 40 pipe also they will go. That depends upon the management. But basic things will not be differ. It will be carbon steel only. Okay, it will be a welded metal only, like that. There will not be any threaded joint. So those kind of things will be freezed at the beginning stage itself. If any special chemical is there, there will be some slight difference will be there in PMS. Usually construction could only considering especially brownfield, what will be major problem they will encounter in those cases? Usually construction crew don't even consider in the piping layout, especially in brownfield. Only thing is a cost only they will encounter in major problem, and then approval from the local body, because it is a brownfield project means they are going to only extend the project. Okay, so definitely it will be easy compared to layout. If you see about the layout now, it will be easy in brownfield project compared to the greenfield project. Greenfield projects there will not be any obstructions, you can play. But in brownfield project, already we have be cornered in one area, because this area only we have to bring the pipeline, because space will not be there. So there on our own we cannot going to decide the routing. There will be enough space only, available space only, we have to make the piping layout. So concern the piping layout, it will be easy in brownfield project. Only thing is, if it is a petrochemical plant, there will be a problem in hot work. A tie-in point area, we have to take more safety precautions. Who will choose which line will go from above ground or underground? In what basis it will be decided? A piping engineer only we have to choose, but also according to the plant area, because in some area, if you see in 90% the fire water line will go below the ground. Why it is going below the ground? If in with a fire incident time, that fire water line also should not get damaged. That is the one thing. Second thing, we everywhere if you take a above ground pipelines, our vehicle movement, man entry, our maintenance, and all will be a problem. So those areas we will take as the underground. But if you take underground, some in our previous plant, we don't prefer underground, because if you take the pipelines underground, then we have to take care of the corrosion, and then frequent inspection it is required, then cathodic protection is required, then wrapping is required. So many things are we have to consider, and then number of pipelines we have to consider, because if it is a bigger pipeline, we cannot take overhead. So obviously we have to go below the ground. That one piping engineer and process people only decide. It's a combined decision only. Who will get approval from the government bodies? In every industry, there will be a separate department will be there. The safety department will closely work together with the government body, along with the quality people. There will be a quality assurance department will be there. They will work close with the safety department, and they will get the approval from the government bodies. What are the problems we will face while preparing ISO with reference to layout? While preparing the ISO with reference to the layout, conversion of layout to isometric. Nowadays, first we will make in the 3D. We will make those drawings, piping layout. That one we will make in the 3D to see any clashes are there or fouling was there. We will see everything. Then we will convert into the isometric drawing. If you choose the distance between one point to other point, you can get the 2D isometric drawing also with the complete details of BOM. So next one is please explain about horizontal and the vertical rolling. Question. Vertical rolling, horizontal rolling is, if you asking this question, you already know about this one. In isometric, they will show if it is going horizontal line, if it go, then they will show horizontally. They will show someone sketched lines. They will show that line will show it will horizontal, and also degree also they will show. Wherever the 90 degree and 45 degree is not required or not possible, there they will mention the rolling. So we have to cut the 90 degree elbow to the 70 degree or a 65 degree, like according to the isometric drawing. In isometric, we will mention in the sketches line we will show whether it is a vertical or horizontal. We can to know about in the isometric. Could you please explain about how to prepare PMS? I already many times we have explained, and last thing Ashwin also took about this one PMS. It depends upon the service. Initial consideration is service, temperature, pressure. Only the basic thing to prepare the PMS. But tomorrow, if there, we will see that one in detail. PMS you can ask again this question by tomorrow or Monday. We will explain. I will explain again. No issue. I will show some PMS example also. I will show in next presentation. I try to show. Is there any software to extract the materials quantities? Yes, it is there. Tomorrow we are going to discuss in detail. So tomorrow you can see it will going to be a full session, 1 hour session. In what basis field shop joints will be selected? Who will finalize the weldman? We already explained. A piping engineer only based on his experience, based on the length of the isometric, only we only decide. Even though if piping engineer is not mentioning the field joint in isometric, the fabricator also can decide whether he is going to do in shop or field. He on its own he can decide, because he is only going to install in the site. Based on the, if we put isometric in like say 10 meter with 2 elbows, if we don't show any field joint, simply we cannot weld that, because handling that, taking the pipeline to the site is a big task. Because while installing the pipeline, already that equipment will be in installed condition, platforms will be there. So you cannot install, simply you cannot install the lengthy pipelines or complicated pipelines. So based on the same condition, based on the pipeline diameter, we have to decide. That both piping engineer and the erection supervisor can decide on that. If isometric is not drawn to scale, then what are the numbers under the pipelines in the drawing? What are the numbers under the pipe length? No, I have already explained. It is not drawn to the scale means that drawing is not to the scale. That means we will show the length of the pipe 1000 mm. But if in CAD or 2D drawing, if you measure the 1000 mm, it will not be in 1000 mm. It will be in 100 mm only in real. That is the scale. Okay. So what number means? In bill of material, we will mention number one pipe we have to cut for 500 mm. Like I explained earlier, it will be in proportionate. In drawing, there will be a three-piece length, 1000 mm, 2000 mm, 3000 mm means we should not show the 1000 mm length pipe longer than the 3000 mm length pipe. Some logic should be there. That is what in isometric it will be proportionate, but not to the accurate scale. Why it is varies plant north and actual north already explained. At what stage conservative review will happen? After isometric preparation, we have to produce conservative review report. We can quantify small bore vent drain valve from P&AD. Can we quantify small bore vent or drain valves from P&AD? Yes, we can. From P&AD itself, 99% of the fittings and valves we can take from the P&AD itself. Without isometric, without piping layout, except the pipeline length, you can 90% you can estimate the fittings, valves from the P&AD itself. Even small bore vent drain valves, everything you can take from the P&AD. With the PMS available, PMS is the Bible for our mechanical fabrication. On what basis insulation materials and the thickness will be selected? That one is based on the heat loss calculation that differs upon the handling temperature. If it is a steam handling superheated temperature, that material will be different. That is different calculation is there. But as a mechanical person, I don't know much about the calculating the thickness. Strainer and steam trap required for which service and which are all the possible locations we can install those items. A strainer obviously it is required upstream of any equipment, particularly rotary equipment, because if it go to the mechanical seal, it will damage the seal, and it will go to the downstream product, it will contaminate the product. So there we need a strainer. In steam trap means before it's going to any turbine or before it's going to any steam control valves or valves, we need a steam trap. Two, steam trap is different, strainer is different. We cannot compare these two because strainer is for filter the impurities. Steam trap is for to remove the condensate from the steam line. But both are different. By steam trap, they will put the strainer meshes will be there because in steam there will not be any impurities except the carbon steel pipe. If it is US carbon steel pipe, there will be some corrosion, some carbon particles will be there. Except that there will not be any impurities because from raw water we using strainer. Raw water has to come to DM water, then DM water has to come to DM tank, then numerous pump he has to pass through. There itself the impurities and all will be gone. Moreover, the steam will be a vapor stage from the boiler. So there will not be any impurities like expected in the water. If there will be a condensate, to remove the condensate, we use steam trap. It will be mostly it will be installed upstream of the control valves or turbines. How many questions? Could you please explain about the interface of piping with mechanical civil? That one we will see in the piping layout itself, or in 3D model we will see the clash. BO and BV is not in the same point of estimation. Why? A bill of material, both are is the same only. Bill of, some people mention a bill of material, some people mention bill of quantity. Both are same only. They will bill of material means they will mention the each and every material specifications with its quantity. Both are same only. MTO only different. It's consolidated BOM only. MTO. Could you please explain about NPSH? That is totally rotary. But we will see NPSH. I will explain. NPSH, there will be a net positive suction head. There will be an NPSH available. NPSH requirement. Both is there. By today already 6:30. You keep ask this question on Monday. we will explain, because Monday we are going to see about only support drawings. Closely we will close that session. We will go for NPSH also. How to calculate pump size and line size? That process person only can explain in very much detail. Piping engineer is selecting the shop field joints, but we are facing too many modifications. For that reason only that question was raised. Yes, that is what I'm explaining. Piping engineer who's having experience in the field, he can 99% he can design correctly. But who is working only in the design, they may not approximately they will fix the field joints, because in professionally we have some thumb rule. In total for any project, if you take now, we will say in the inch dia basis, because while estimate the cost of the project, we will say how many tons of steel, how many ton of cement, like that, how many ton of steel. Now same like that, we will check the how many kilogram of each pipeline, like that, how many number of walls. Same like that, for fabrication purpose, we will consolidate into the pipe inch dia. So per inch dia we will pay 100 rupees. Per inch dia we will pay the one this much dollar, like that we will decide. So based on the inch dia, any project will go the 20,000 inch dia. If you do 1 inch, one joint means it will be 1 inch dia. If you do one joint in 10 inch pipeline means it will be 10 inch dia. This is the calculation. So irrespective of the sizes, we will consolidate, estimate the inch dia for the whole project. 50,000 inch dia it is coming. So 50,000 inch dia means per inch dia this much dollar. So our fabrication cost will be this much. And then erection quantity 1 inch dia per meter, like that there will be some estimation will be there. If 50,000 inch dia is there, out of 50,000 inch dia, let's say 5,000 inch dia or 6,000 inch dia will be at the field joint. Like that we will, one thumb rule we will have based on the pipeline sizes. So based on the piping engineer will select the shop and field joints. But better piping while fabricating, that fabricator, if he has experience, he definitely he will know. So this pipeline, this joint we cannot do. Like one question is asked, rolling, pipe rolling. So those kind of joint we should not do in shop. We must do at the field only. Otherwise, rework will be there. Your inch dia, your cost, your time, everything will go higher. That's it only. Is isometric drawings are drawn at default angle. Angle means he's asking about north or not, but generally we take the north only as a coordinate. We will make the isometric drawing. Okay, I think those are the questions. Anu, can we conclude?
Yeah, sir. We can conclude. Thank you for patiently answering each and every question, and also participants. Thank you for asking questions and patiently listening. So I think there's no more questions. We can conclude today's session. You'll be having the assessment of this module tomorrow from 11:30 a.m. and we'll continue tomorrow with the same topic, part 2. So thank you, everyone.
Thank you,
Thank you, sir. Thank you so much.
Thank you, sir.